Uh, we were on the octagon, and so we need to find all the lines of symmetry. So you've got this one. It goes through the two vertices, but then also through each middle side part here. So you've got 8 all around. If we start here, there's 1, 2, 3, 4, 5, 6, 7, 8, and notice that this line hit back where it was there. So 8. And then again, we need degrees rotation. So if you do 360 divided by 8, you end up with 45 degrees. And if you want to list those out, you're listing multiples of 45, or you just keep adding 45. So 90, 135 is 45 again, is 180, is 45 is 225, 270, 315, and then 360. And those are the degrees of rotation. We're going to copy the angle. So when you go to copy an angle, you do actually need to start with a line segment or something you're going to copy onto. And here I'm going to mark the point, the vertice of the angle, and I'm going to do the same thing there. So we're going to take our compass. Remember, for this one, you do not need to you can draw the arc any measurement you want to. So there's my arc, and I take that same compass measurement and I drop it on this line here. Oh, it only likes to go one way. And then we're going to do the same thing, but we're going to measure our compass from the vertice that we just got. So right here, I lined it up. Here, I've got it pointed at, so we got the tip of the compass here, and we've got the other pencil piece at the top. So I'm going to, okay, I've got it lined up. I'm going to move it down a little if I remember how to work this thing. We're going to swing it through, and we're going to pick it up, take that same arc, and swing it through. Notice that here is now this point is where I connect. So if I want another straight edge, I would take my straight edge, connect from the center, and that is copying the angle. So this arc that you start with can be any length that you want it to be, and then you measure from the intersection to the intersection point. Again, remember when you draw that first arc that you drop it down on your other angle so that you have that same arc there, and then measure from the intersection to the intersection. The next one, you've got construct a perpendicular bisector. So on this one, you're going to line up your vertex. We are going to move our pencil so it's on B, and we're going to swing it through. And we're going to do the same thing, and we're going to swing it down. And then we're going to switch, and we're going to take that same measurement, we're going to run it through the other way. If you want to keep going with your circle, keep going. But you don't have to, because what we really need is where it intersected. And in this case, it intersects here and here. And if I take my straight edge and I connect from one point to the other, I have constructed the perpendicular bisector. because right here, this is a 90-degree angle, and we have cut this line into 2 equal parts. And next year, you are going to have to prove that mathematically using congruent triangles. But for now, we're going to just make sure we know how to do the construction. The next one on there, we're going to bisect the angle. So we're going to start with our compass point on the vertice. And again, on here, I can make this angle any size I want to. Just like that last one that we did with the angle. We're copying the angle. It's very similar to that one. So we swing an arc any size you want to. And then we're going to put the point on the intersection. And we are going to close this in so that we are measured right at the other intersection point with our pencil. So we're going to take this, we're going to swing it through. If you want to keep going, keep going. And then we're going to flip it. So our tip is at the other intersection point, and our pencil is lined up. We're going to swing it through the other way. And where they met right here, if we take our straight edge, that point and the vertex of the angle, we have now bisected this angle or cut it into 2 equal angles. And that's bisecting an angle. And finally, we've got on our paper, the last one is inscribing a regular hexagon on a circle. And I believe in class I said that you have to draw a radius first. Technically, you don't have to do that. So we're going to put our pencil in the center, and we're going to swing our arc through. And then we're going to do the same thing. Now with our vertex on where the intersection was. So we're going to line it up, and it is already. And we're going to swing it through again, and we're going to keep going around the circle just like that until we come back to the beginning. So swing it through, line it up with the vertex, and swing it through again, line it up again. Oops, wrong point. Line it up again. Make sure it's lined up here. Swing your pencil through. The tip of the compass again is on the intersection. Pencil is lined up through the center, and we'll swing it through again. Notice that right here, it should come back to where we started. And now, if we take our straight edge and you have your 6 points on the outside, you are going to connect those, and that is a regular hexagon. And that's all. There it is. And to mark it as a regular hexagon, we should actually put these marks on it to show that all those 6 sides are equal in length. And I know a lot of you were confused about the square in class, so I'm going to do that one real quickly here. If you've got a circle, and yellow is probably not the best color, so hang on. We'll get rid of that. Here's our circle, and the center of the circle we'll say is about right there. I am guessing, but you get the idea. So if you draw a diameter through the center of the circle, this is the easiest way to do it. We would draw the diameter, take our compass, line it up on the vertice, and then we're going to draw a perpendicular bisector from here. So I need a bigger compass to do this. It's a little bit tricky with this thing. We line it up and swing the arc through. Uh-oh, not going to be able to see it up there or down there. Technically, though, we don't have to go all the way to the end, so I'm going to come in a little bit so that you can see where the intersection points will lie. And then flip it to the other point. I did not change my compass setting, and I'm going to go through. And then from here, if you draw where they intersect, if we draw a line through there, this is bisected perpendicular, and you would connect here to here. Again, I'm not using the straight edge because the video is going to cut out, but if you connect the points on the edge of the circle now, that is your perfect square. If you have any questions still on this, you should come in before or after school or during advisory time. Study hard.